Working long hours is a way of life in Japan, so much so that some occasionally die from it. Karoshi is a term that means death by overwork. So why are people working so hard, and can it be fixed?
Japan has some of the longest working hours in the world. Nearly a quarter of Japanese companies have their employees work more than 80 hours of overtime per month. Those extra hours are often unpaid. Today, Japan's corporate culture is driven by the so-called salaryman.
The salaryman is defined by his loyalty to his company
And expected to spend his entire career working for the same firm.
Not only does he work long hours in the office, but it's also assumed he'll participate in after-work activities too, like drinking with colleagues.
And they're not taking enough time off. In 2017, one survey found that despite being entitled to 20 days off per year, Japanese workers left 10 of those days unused, topping every other country in the survey. You don't have to be in the confines of corporate walls to feel the impact of its work culture.
It's 3 a.m. Thursday morning right now in Tokyo. I'm in the area of Ginza. Every few minutes I see a man wearing a suit holding a briefcase.
The nation's work ethic dates back to what's referred to as Japan's economic miracle, which was its dramatic economic growth beginning in the 1950s, which propelled it to become the world's second largest economy. Inside Japan's corporations, the culture emphasizes the success of a company as a whole to be more important than any single individual, which might explain why one study found that 63% of Japanese felt guilty for taking paid leave. But perhaps more concerning is this: long work hours don't necessarily mean high productivity. In fact, Japan has the lowest productivity amongst the G7 nations. Earlier I mentioned the term karoshi. It means death by overwork. It's legally recognized by the government and usually is marked by a heart attack, stroke, or suicide due to stress. There's hundreds of cases of karoshi reported annually, although some argue these cases are underreported and that the real number could exceed that by up to 10 times.
An employee of the advertising firm Dentsu jumped to her death in 2015. The cause was said to have been depression caused by overwork.
The case generated widespread attention and renewed calls to change the long working hours and illegal unpaid overtime, highly common in Japan.
The firm was fined for violating labor standards because she was reportedly forced to work more than 100 hours of overtime per month.
The company's CEO even resigned over the controversy.
After the death, Dentsu made some changes within the company. One of them, the lights in the office now turn off at 10 p.m. every night in an effort to force employees to leave. Both the government and companies are now actively trying to reduce the number of working hours here.
And there are some early signs of hope. Japan's government has considered several initiatives to curb the number of hours spent at the office, including making it mandatory to take at least 5 vacation days a year, and requiring a rest period between the end of one day and the start of another. In 2016, a new holiday, Mountain Day, was started, bringing Japan's number of annual public holidays to 16. And in 2017, the government launched an initiative called Premium Fridays, in which it encouraged companies to allow their employees to leave at 3 p.m. on the last Friday of the month, promoting consumer spending and less time in the office. But one study found that less than 4% of employees in Japan actually left early on the first Premium Friday. Which is why, despite these initiatives, a cultural challenge still looms. Since Japan's culture emphasizes the group over the individual, well, no one wants to be the first one to leave the office. And there's another reason that there's pressure on people to work hard. Japan's economy is in danger, and in order to maintain its massive size, Japan needs to put in the hours. Japan lost its spot as the world's second largest economy to China in 2011, a title that it had previously held for 42 years.
Japan is dealing with a labor crisis. Its population is aging fast and its birth rate is in decline. That means its total population is going down.
And in the next 50 years, it's projected to shrink by nearly a third. The population is expected to go from 127 million in 2015 to just 88 million by 2065. There's 2 likely ways that a nation can compensate for the labor shortage: immigrants or robots. Japan has always been less inclined to accept immigrants. In fact, its percentage of foreign workers is tiny compared to other nations of large economies. So without more immigrants, it's looking to robotics to fill in the gap. Its robotics industry has spanned from hospitality to manufacturing, and now even reaching farms by creating robots that milk cows. But whether technology could open the door for a better work-life balance for Japan's workforce still remains to be seen.
Hey guys, it's Upton. Thanks for watching. For more of our videos, check out what does equal pay mean for the economy here, and will robots take our jobs here? We're also taking suggestions for future CNBC Explains, so leave your comments in the section below. And while you're at it, subscribe to our channel.
Various types of sequencers and indicators are assembled on the 5th floor, and different work procedures and parts are used. For this reason, the cell production method was employed more than 10 years ago. The cell production method is suited to manufacturing various products in small lots. Mistakes occur because a single worker performs the entire work. In addition to skilled workers, quite a few inexperienced workers, including newly assigned ones, work at the production sites. To reduce mistakes, Nagoya Works started to work on improvement more than 10 years ago. Over the past 10 years, the number of mistakes has been reduced to 1/10. The E-Factory technologies were fully mobilized to achieve zero mistakes and renovate the sequencer assembly cell on the 5th floor. Collaboration between workers and machines has been ensured. This assembly cell features a job instruction system, which was built by combining our sequencers and indicators. Now let's take a look at the screw tightening job instruction system. There are two key points in the work: using the correct parts and installing the parts according to the correct method. In the screw tightening job instruction system, the indicator screen in front of the worker displays the type and number of screws and the type of electric screwdriver to be used. The LED lamp lights up to indicate the next screwdriver to be used. The worker can accurately take out screws and select the next screwdriver without checking the job instruction. The indicator displays the screw tightening position and tightening order. The color of the tightened screws changes on the display so that the next screw tightening position can be checked at a glance. In addition to instructing the work procedures, the system can automatically determine the quality of screw tightening by using the sensor installed in the back of the screwdriver. If a screw is not properly tightened, the red patrol light and buzzer informs the worker of a problem, and the screwdriver is turned off to prevent the worker from performing the next job. All the data of screw tightening torque and time is collected by sensors. The data is linked with the products, workers, and dates and times of work, and is stored in a database on a real-time basis to ensure traceability management. This instruction system has made it possible to standardize the work and eliminate dependence on the experience and senses of skilled workers. This cell production enables newly assigned workers to ensure high quality in their work. The work improvement is facilitated by analyzing the huge amount of data derived from the instruction system. For example, the work time of each worker can be identified based on the graph of the average work time. Intensive training can be offered to workers who take a long time to complete their work. The number of improperly tightened screws can be displayed for each worker. Effective training can be offered to workers who often cause screw tightening defects. The quantitative data is automatically collected, and the effect of the training can be checked at a glance. The graph showing the number of defects by work process helps identify the processes in which screw tightening defects often occur. improvements can be made quickly by jig replacement and design change. The instruction system has helped standardize the assembly work. The man-hours required for training newly assigned workers have been reduced to 1/3 through pinpoint improvement activities. The familiarization period has been halved, resulting in a significant increase in productivity.
Hi there, my name is Ron Pereira and I'd like to officially welcome you to this first overview module of the Gemba Academy 7 QC Tools course. Well, by the end of this module, you'll know what quality control is, you'll understand the benefits of quality control, and you'll know what the 7 QC tools are. And you'll also begin to see how the 7 QC tools can help your organization improve no matter what type of work you do. To be sure, you don't have to manufacture widgets to practice quality control, as we'll learn throughout the rest of this course. Okay, well, let's get things started by offering a definition of quality control. And to do so, we're going to hear from one of the giants of quality control, Dr. Kaoru Ishikawa, the person credited with defining what we call the 7 QC tools today. Well, when asked to define what quality control was, Dr. Ishikawa said that it consists of developing, designing, producing, marketing, and servicing products and services with optimum cost effectiveness and usefulness which customers will purchase with satisfaction. Now, from this definition, it's clear that Dr. Ishikawa felt quality control was far more than visually inspecting parts at the end of the assembly line. In fact, Dr. Ishikawa often spoke of total quality control, or TQC, which saw quality control spread to all facets of the organization, including front office tasks. So that's what it is. Now let's turn our focus to the benefits of quality control. First, when quality control becomes a way of life, the number of defective products will decrease, and as such, over time, customer satisfaction will increase, leading to enhanced trust and loyalty. And from an internal perspective, consistent quality control lowers costs for the company since people aren't wasting time reworking parts and waiting for good parts to be produced, and as such, profits increase year over year. So, you see, done correctly, quality control reaches all aspects of our business, which results in happy and loyal customers. Now then, the tools most often used for problem solving by organizations well versed in quality control are called the 7 QC tools. Now, for the rest of this module, we'll take some time to introduce them, and then throughout the rest of this course, we're going to be taking a deep dive into each tool, explaining how they can be applied in both manufacturing and transactional environments. But before we get into the tools, I'd like to provide a little background on how these concepts developed. And as it turns out, the Japanese began applying quality control during the 1930s and 1940s after Dr. Walter Schuhart and Dr. W. Edwards Deming introduced the concepts. And Dr. Kaoru Ishikawa, the then head of the Japanese Union of Scientists and Engineers, decided to expand the use of these tools in the 1960s with the introduction of what we now call the 7 quality control tools. Now, Dr. Ishikawa chose these 7 tools as a way to make the use of quality control accessible to anyone, no matter their experience with statistics. Well, the first of the 7 QC tools is the graph. Now, most of us have seen or used graphs at one time or another. With graphs, data are expressed to easily compare quantities or quantity changes. They're also used for arranging data, sharing information with others, and making judgments. Now, in our next module, we'll not only explore several different types of graphs, but we'll also explain how to choose the correct graph to use. The second QC tool is a check sheet, which are tables used to arrange data by type. Now, we also use these simple but powerful tools for checking if jobs are completed without problems and for preventing mistakes from happening at all. The third QC tool is the Pareto chart. Now, Pareto chart classifies problems and defects by type in the order of quantities and shows a cumulative total. Now, Pareto charts are often used for checking a problem or defect to be highlighted for solution. In other words, Pareto charts often help us identify where the problem is, as we learned about in the Gemba Academy Practical Problem Solving course. And as a reminder, Pareto charts get their name from Wilfredo Pareto, the Italian economist who was the first to identify the so-called 80-20 rule. Well, the fourth tool invented by the aforementioned Dr. Ishikawa is the cause and effect diagram, sometimes called the fishbone. Now, the cause and effect diagram systematically arranges the results of effects and the factors that influence them. With this information, we're able to classify causes and their potential influence on the problem at hand. The fifth QC tool is called the scatter diagram, which is a graph used to examine the correlation between variables by plotting corresponding data. In other words, scatter diagrams help us understand the relationships between two variables and whether or not they're associated or correlated with one another. Now, we'll get into different variations of the scatter diagram, including regression, later in the course, but I do want to mention an extremely important aspect of studying correlation. Namely, that correlation does not automatically mean there's causation. Now, an example of this is how in some cases it can be statistically shown that as the number of liquor stores in a town increases, so do the number of churches built. So one could conclude that if a town hoped to have more churches, all they need to do is build more liquor stores, right? Well, of course this is complete nonsense, since the two, liquor stores and churches, aren't correlated at all. Now, a better explanation for this situation is that as a town grows in population, there'll be some who like to visit liquor stores and some who like to attend church. Next, we come to the histogram, which is a graphical display of numerical data in the form of upright bars. With histograms, we're able to learn many things, including how much variation or spread a data set contains. Now, when we add in customer specification limits, which we'll learn more about later in the course, we're able to calculate something called CP and CPK, which basically tells us how well our process meets customer requirements. And last, but certainly not least, we come to the control chart, which is a tool used for judging the situation of quality values against control limits in order to check the stability of a process. Now, control charts also help us to understand whether we're dealing with common cause or special cause variation, which is an extremely important information to know as we work to control quality across all levels of the organization. Now, we first learned about common cause and special cause variation in our practical problem solving course, but as a quick refresher, common cause variation could be likened to the normal everyday traffic we experience on our commute each day to work. And special cause variation could be likened to when there's an accident and traffic comes to a complete standstill. All right, well, those are the 7 QC tools. As promised, throughout the rest of this course, we're going to take a deep dive in each one separately, explaining how the tool can be applied in both manufacturing and transactional environments. Additionally, throughout the rest of this course, we're going to learn how to create each of these tools using Microsoft Excel and Sigma Excel statistical software. All right, well, this wraps up this overview module. In our next lesson, we're going to dive right into things as we gain a deeper understanding of the many different types of graphs available to us. So, we'll speak to you soon.